Hey folks, how's it going? Welcome, welcome. Just getting some things set up. Let's see. Well, things look a little red today, don't they? I don't know if that's is that the normal lighting? Let's see. I think that's what we're on. We want some cooler lighting today. Maybe we go cooler today. All right. So, welcome. Today we're going to do some hacking on jank. Who would have guessed? Who would have thought? We got a fun one in store, I think. We got a couple of things. One main thing we'll try to get through, and if we get through that, then we'll see what else we can tackle after that. So the main thing I want to do is I want to remove tagged literals. I want to remove the need for tagged literals. Let me show you what these are, so that we're on the same page here. So this is the jank book, and well, this is the source of the jank book. And for the native value section, we have this section on tagged literals. And so these are integers and floating point values and strings and bools. Actually, we're actually missing. I guess we have that here for CVP true and CVP false. So I'm pretty sure we support the CVP reader macro before true and false as well. We just don't put it here. But anyway, I'm not going to fix it because I want to remove these entirely. So my goal here is to have 0 and 3.14 and meow be the native types by default. And the reason that they weren't to start with is that we've only had this sort of C++ interop that we've had for a little over a year now. Actually, yeah, about a year and a month. So, but the rest of jank has been around for a lot longer than that. And so we started with, like 0 being a jank object. That's a boxed jank object. And we had boxed floating point values. We had boxed strings. And we still obviously want to keep all of those, but now that we have really good interop with C++, it makes sense to just default our literal values for integers, floating point values, strings, and bools to just be the C++ value. Now, where you'll see this show up is in a lot of interop. And so if you have like a function that you're trying to call that takes in some floating point values or integer values, and you find yourself just doing this CPP reader macro over and over and over again, it just gets really messy. I just don't like it. And there's no good reason that it needs to be that way. There's no good reason that we want to default to these literals being boxed jank objects. It's just a historical artifact. So let's fix it. So the main benefit here is it's just going to clean up interop. So when we're calling C and C++ functions that, like we call a C++ function that takes an integer, then you can just pass your integer literal and not need to worry about it. Now, we do have some support for doing that already, where the jank compiler will detect this thing takes an integer and you passed a jank object. Let me add an implicit conversion for you. And that works in some cases, but it doesn't work in all cases. And that's just because C++ is complex. So I'm trying to simplify that. This will be less for people to think about of, do I have a this object or do I have a this literal? Instead, it's just pass in the stuff you want. I think it'll be more intuitive. It'll have fewer surprises for that to work. I don't have a 100% clear plan of exactly how this is going to be implemented. I've thought a little bit about it, and it seems like it should work fine. But we're gonna see if we're gonna see if we run into any roadblocks. I don't know. We will see. So let's jump into it. When we think about where this needs to change, we're going to end up removing this CPP reader macro for these literals, but we won't do that until the very end. Do we need to change anything with parsing or lexing? No. We're still going to read these in the same. But when we go to analyze just the normal number, so when we go to analyze, let's say 0, and a bunch of shit here. There's nothing here that I want to... There's nothing here I want to build upon, though. So let's just start our own thing. I'm going to delete that because it doesn't matter. So if I do something like this, this is basically... Let me show you what this looks like now. So we'll do a jank print. Let's just do a code gen. Test.jank. So now the way that looks is that we have a small integer ref, which is this v2. If we print the IR, then we can tie these things together. So our let has nothing but I is 0, right? But the let implicitly returns nil, evaluates to nil. And then because it's a top level expression, it gets wrapped in a function. So we have this function user let. So has a scope and parameter, implicit let parameter for the function object. Now the let that we actually wrote is this guy. Inside of that, we have a literal, and this literal has the type of a small integer ref. And so this is a boxed object. And then we have our literal nil, which is what we're going to be returning at the end. And so that's all we do is just we return it. And so v2 here is basically our I. We just didn't use I anywhere, and so we don't actually see it referenced. We like it's here, but it's not referenced anywhere. So we do our return, and then we close both of our scopes. And so when we translate that to C++, it's the same thing. Here's our v2, here's our boxed integer. We grab nil, and then we return that. We close our scopes. That's it. Now, what I would like this same code to actually be is something more like this. Actually, we'll just do this version. So with this one, we end up actually generating a helper function to give us that literal. We should remove that. Yeah, we should remove that. Maybe we can do that as part of this. But this is actually a function that we generate as a helper that will return an int32 for us, which is basically just an int. It has an alias here, JTLI32, so we can be more Rust-like in our runtime. But it's just an int. So v2 is just an int here, and then we return nil just the same. So what we actually want is this I0 to behave the way that this does. Although ideally we'll remove that helper function and we'll actually just use a literal there instead. So let's try to make that happen. I think this is going to start an analysis. where when we analyze literals, we're going to need to change the type of the literal that we are analyzing from a boxed object to a native type. Hey, Alex. Good evening. How's it going? Okay, so where do we don't actually have an analyze literal here. I think we have a literal type function. Oh wait, primitive literal? Analyze primitive literal. Go here. Okay, so here we just create a primitive literal expression. Trying to get a Rust port of your embedded project work. Oh, cool. What'd you port it from? So for our AST, maybe we don't even need to change anything. If we can just keep our primitive literal expression, and that can handle, let's say that handles C++ literals as well as jank literals. Because we have other literals too, right? That aren't going to be C++ literals, like a literal map or literal vector or a literal set, so on. Literal regex. It's really just the numerics and string that we want to treat specially. Last semester, you built a Scala robot? Cool. That's pretty neat. Okay, so let's take a look at primitive literal. Okay, so each AST expression has a get type function. That's a virtual function. So here's the primitive literal struct, and then we're overriding get type. This comes from expression. This is our common base for every AST expression. And so we have this virtual get type function. So here, the get type for primitive literal calls this literal type helper. This is going to do a switch on the type of the object because we have some jank object and we want to get the literal type for it. And this is going to give us all boxed stuff. And so I think that our first goal is probably to just change this literal type guy. So for example, for Boolean here, we won't do a Boolean. We won't do a boxed Boolean. We'll actually just do a bool type. And then here we'll do an int type. Now, there's some trickery that we're going to need to. I'm probably going to just to do it for now, which is that in C++, integer and floating point types scale as your literal gets larger. And so if your literal can fit inside of an int32, then the type's just going to be an int. But if it gets larger than that, then it becomes like a long, and if it's hexadecimal, I think it's unsigned. I don't know. Like, well, I'm gonna have to like look up what the standard says for exactly how those rules work. For now, we're just gonna hard code these things to int. That's gonna get us most of the way, and then we'll just go in and we'll patch that up with the correct logic. Thanks, but the fact that you're traditionally coding a compiler on your own is crazy. Nah, not crazy. I think, yeah, people, I think that the compiler community probably enjoys the notion that compilers are are so complex, and like, oh, we have like the dragon book, and it's all magical and dragons and arcane and everything like that. But I think the compilers are, I think that they're just another application. Now, of course, there are people with PhDs in compiler development design who are doing crazy, like frontier pushing shit, of course. And those people are indeed, doing arcane magic. But like just general, the general sort of glue work of checking, doing lexing and parsing and semantic analysis in code gen, I think is approachable. Is something that people get into if you are interested. But I appreciate the kind words either way, Alex. The only reason for the monologue there is that one of the things that I like to do, now that I do compilers, I guess for a living, is just try to dispel some of the fear that people have around them. To just be like, look, man, or gal, you can do this as well. It doesn't need to be stupid complex. It can be pretty straightforward. Okay, so let me check before we go in and just start patching this literal type guy. I want to see where this is used. So let's see. We define, we use it in primitive literal, cool, and then we use it for CPP processor, and this is our C++ code gen when we're lifting constants as well. That's perfect. So we'll just use it for primitive literal get type, and then we'll use it for getting the type of lifted literals. Nice. So that means that it's not used in any place where I'm like, oh, how do we manage, both of these things? Kuiman, he's saying C++ is simple. No, like C++ is not simple, but compiler development doesn't have to be in C++ either. I'm just saying that that compiler development is more approachable than a lot of people liked. I think they like the stigma around like, oh, the compiler development so difficult and amazing, but it's just like, like to do a basic interpreter or a basic compiler is just some data transformation. C++ though, C++ is ridiculous. Aren't you essentially building a C++ compiler since you have interop with it? Well, I mean, I'm dipping into it for sure. But the thing is that jank is built on Clang as well. And so this whole get type from scope, resolve scope shit, like this, if we jump to the definition of this, we're dealing with Clang types. This is a pointer to Clang decal. This is Clang's AST context and function template decal. Like this, all of this comes from Clang. And so the jank compiler, like we do our lexing and parsing and our semantic analysis of the jank code. And then we also we have our own concept of the world. And then we also build up, or like a corresponding concept of the world in Clang. And then it's our job to keep those two things in sync. And we do have some bugs where those things kind of go out of sync. And that allows us to do all of our type checking and everything like that, because jank actually uses the C++ type system, because it is, like, I think of jank as a dialect of C++. Fortunately, we don't need to write a C++ compiler, because Clang does a lot of that for us, but we do need to deal with a lot of the bullshit around C++. But normal compiler development, like if you just want to want to write a simple, a simple Lua or, or Python style thing. You don't have, obviously you're not going to be dealing with Clang, AST, C++, interop. Do a lot of people in compiler dev use AI? I hope not. Kind of don't like them clankers. I don't know. I think yes. I think, just based on what I see, people just use AI these days. Obviously not everybody, but a lot of people. And when I think about the big names in compilers, they are not all of them. I think like John Blow, for example, is not using AI at all for Jai. But like Phil Peaslow, who's doing like Phil C, he's using AI quite a bit to solve problems. Obviously, someone like him, he knows exactly what he's doing. He is an expert wizard in compiler development, and then he's using AI to help him implement shit that he otherwise wouldn't have time to get to. So it's different from someone just vibe coding something, but it's still what it is. Reminds you of the whole Zig Bun situation? Yeah, that's quite the situation. I hope that Jank doesn't get into any sort of drama like that. I will do what I can to make sure that that we as a community remain, I can't promise drama free, but far more avoidant of drama. Drama means, because I know, Kuvi man, I struggle with this, man. I fucking struggle with this because I look at these other language devs on Twitter and Hacker News and everything like that, and I'm just like, man, they're getting so many fucking views, but the way that they're doing that is by like roasting other people or just like putting out zinger drama posts, and I'm just like, man, how can you just be like a nice BDFL and succeed? I think it's possible. I think it's probably a lot harder. But then again, so is doing C++ interop. So we'll take, we're choosing our own bed. We're gonna lay in it. So we want to get a bool type here. Let's get a bool type. Do we have a bool type? We do have oh fuck yeah, we have a bool type thingy. So bool type. Hey Braxton Rivers, welcome to the stream. Hope you're doing great. Do we have an int type? Not gonna lie, it would be cool to see more compiler devs stream work. Yeah, Alex, check out Kuviman, who's in the chat. Follow him on Twitch as well, because he does compiler dev as well. But I do agree that there should be more. There should be more. It would be great. Does Jank have t-shirts or swag yet? No. I was considering printing some and bringing them to the conj to see if people wanted them, but we don't. But we don't right now. Braxton, Thursday morning down under? Ah, nice. Hopefully not too early. Okay, so we don't have anything for int here. Let me just add some helpers for this. So I want to do an I32 type. No, int type. So we'll do int type and bool type, and let's just do float type, float. And then the other thing that is going to be trickier is that we're going to need to turn strings into array types. 7:30 a.m. eating brekkie. so what's the term I want? Adorably Australian. Recently saw the Clojure and Ruby docos on YouTube. Here I am. Nice. We're glad to have you. Glad to have you joining us during your breakfast. Let's see. Okay, so we did you say you do compiler living for or compiler dev for a living now? I thought I just read Jank announcement this year. So Kuyaman, I quit my job to focus on Jank full time January of last year. So it's been a year and a half of full time work on Jank. Now there is a difference between working on Jank full time and actually making money. So I do make money from sponsorships on GitHub, as well as open source grants that I get from Clojures Together. But there's a difference also between that and being able to pay the bills. But yeah, I mean, I do this full time for a year and a half now. Gonna try to keep going until it either works or it doesn't. To be decided. Okay, so we need to handle differently sized types depending on the value. So if it's a small integer, we actually know small integers we know are already 32 bits. So we can just do this. You could apply for open source sponsorship by the Bavarian state. I'm not familiar with what that is, Alex, but I could look into it. Now, we're not going to do literals. We're not going to do native literals for characters because Jank supports Unicode character literals, and that's not going to translate to a 1-byte character literal that C++ has. In case you were wondering. Widening? Yeah, for sure. We're going to add the logic for proper widening later. Before this gets merged, but not right now. They're trying to get away from America because they think they start to invest money in open source projects. Ah. Yeah, America do be like that. So we want differently sized types here. Okay, and then persistent string. So this is the only other one. And so for persistent string, what we want is we're gonna want a so let's do a C string type, And let's choose a size. So we'll do a uSize const size. And what we're going to need to do is we're going to need to get an array type. So I believe if I just jump to the header, there is get array type, and there's also an overload that takes a size. Isn't that handy? Isn't that so fucking convenient? So let's do get array type, and we want char and size. Why don't you like that? Oh, because it takes a type. So we need a char type. Ah. Okay, so int type, char type. What do you want? What are you complaining? Wait, we already have char type? All right, we already have char type. Yeah, char type is special as well because we have to resolve it differently. Otherwise, Clang turns char into signed char. Now, this is an interesting thing. So char, just like int, is automatically signed, right, in C++. But when it comes to the AST, there is a difference between the canonical type of char and signed char. They're not actually the same type because one is explicitly signed and the other is not. And so that can then lead to problems when you start comparing types and trying to do certain substitutions and whatnot. So we were having a problem before where we would try to resolve char as a type, and then what we get back is a signed char, and then that ends up being a problem. Isn't that fun? That's a link to the official website with a sponsorship. Cool. I'll take a look. Thanks, Alex. I appreciate that. Muy amable. So let's do a char type here. And so now we get an array of char type with size. Now the catch here is that the size needs to contain the null byte as well. And so do we want to expect that in the parameter? No, I don't think so. So I'm just going to do a +1 here. And then what we'll do is we'll jump to persistent string. And so right here, we're going to, we're just going to yoink this, I think. Okay. And so this will be C string type. Now we need to grab the actual string data. So we'll do an expect object. We know that this guy is already a persistent string, so we can cast it accordingly. Object type, persistent string. Thank you very much. And I believe our object was called O. And can I do this? No, apparently not. Data, and I'm off. I'm behind a window now, so I can't actually see what I'm typing. Size. What's the problem here? No action call. Okay, so what is O then? O is an object ref. It should be fine. Expect object, runtime object. Oh, this is the problem. So I don't want the object type here. What I want is just the obj here. If you understand it correctly, you're in favor if you're living in the EU, but it's not a requirement. Gotcha. I am not in the EU currently. I wonder if we're just missing an include. No, we have RTTI there. Let me save this and see if I actually get an error. Because I don't quite believe that. They already sent some money to the Zig Foundation? Okay. Yeah, I mean, Andrew Kelly is... he is not too far from me. Down in Portland, Oregon. A few hours drive south. Yeah, object wrap. I wanted this one. Constraints not satisfied with t equal to persistent string. Why? 56? Object like? Okay. So we're missing the include for persistent string? Where is string? I could have typed it, but I committed to tabbing all the way through everything. Please don't hold you accountable. Oh no, you're so accountable now, Alex. If this doesn't go well, I'm gonna follow up with you. You're gonna get an angry email. I'm just fucking with you. I don't know. I don't know if I've ever written an angry email. Okay. Okay. So now we're starting to generate C++ code accordingly, and then that's breaking because the rest of our C++ code generation is not updated. So let's see. So this is our literal type. If I recall correctly, there's another function. Yes, there is, called literal codegen type. The only difference here, I believe, is... Okay, so hash maps can become array maps if they're small enough. Integers can become small integers if they're small enough. And that's it. Otherwise, it's the same as the codegen literal type. So this integer shit doesn't matter. And then we really just we don't even need all this other stuff. Really, we could just check if it's a persistent hash map and do this logic. And otherwise, just give us the normal literal type. You know what I'm saying? So let's just do that. Let's just do that. So we'll just say if get type is equal to... Also, why do we have a jank on that? I don't know. And then there's our curly for that. And then otherwise we just return literal type of Yeah. Majority of members all present voted against the surveillance law. Yeah. Best time to hold a vote also is right when people go on vacation. Okay, cool. So that all compiles and links and then fails to do code gen for closure core, which is what we were seeing here. We're just going to see it again because we haven't changed that yet. Don't jump ahead. So that's analysis done. And all we did was we just went to the function that determines the type of literals, and we changed it to give us the native type instead. So integers, small integers get int type, bool gets a bool type, and our boxed reals get a float type. And then we'll handle the widening in a bit. So the last part should be during code gen for these. First off, let me see what we get here. So I'm just doing the I is 0. Why would someone who is not suicidal or mentally sick code in CPP? I mean, why would someone come into someone else's stream and be mean? You don't have anything better to do? So we have a literal of closure core. This is a conversion. Why are we doing a conversion here? Is it because of the macro? No, it must be some closure core stuff that we're compiling up front. Oh, it's because closure core is not loaded. And so we're trying to, we didn't AOT compile closure core because we failed to. And so we are trying to do that now. So if I remove the loading of closure core, all right. What are we doing on line 71? Ah, fuck. We're trying to do some closure core stuff again. I used to be able to just comment out that one line. It was like a long time I was used to just being able to comment out that line, but now we enter the username space and then we refer closure core. Used to be that we always just defaulted to being in the closure core namespace. Okay, let's take a look at what we have here. So we have our literal 0, which has the type of int, which is great. That's what we wanted to change. And so our IR now reflects the correct stuff. But then our code gen is mixing types, our native type, as well as the old code gen for this. So let's fix our code gen for constants. In particular, the code gen for integers and floats and bools and strings. So we have a couple of different places I think that this needs to happen. So we have right here, lift constant. If we're eval, then if we have a typed object, and so this is actually based on the type. And so the type is going to be, I think what we want to check here is if is any object and negate that. So if we don't have a jank object type, then that means that we have some other sort of native type. In that case, what we want to do is we just want to, I think, turn the type into a string. So I think if we just do a not type, we just want to turn the object into a string. So if we do a to code string on that guy, then that should solve that use case. And then this code should probably just work after that. Our simple let I is equal to 0 anyway. We'll still have other changes for other bits of code. Yes, this does work. Great. So here we can see that we just initialize v2 as 0. And so as long as our logic matches the C++ logic, we don't actually even need to specify the type here. We'll just rely on auto. And then the generated C++ code will have the same type as the internal representation of the AST, assuming that logic matches. Right now, the logic doesn't match because we're not doing the widening as we need to. But in this case, 0 is still going to be an int. So in this case, it's correct. It's just that in larger cases, it won't be correct. That's fine. We have what to do for that. So that's that case. And then I think we can remove this. We can remove these cases because this shouldn't be needed anymore. So that means that we can combine these two. Aren't these the same? Yeah, they are. Cool. So now the only other part is that we have this gen constant function, and we just have to handle it right here. So here we're doing a call to jank small int. Oh. Okay, yeah, we won't worry about that yet. There's a little more that we could do to improve this, but we're not going to worry about that just yet. What we're going to do is we're just going to do one of these, or do one of these. So we're just going to format the data directly to a string. And then since these ended up being the same, we're just going to combine those. Otherwise, the compiler is going to complain at me. And then the last one is the persistent string. So for this one, we are going to do the similar sort of thing right here. And we're going to do that. We're going to do that. And we'll do code string. And that's it. I think that's it. And we managed to compile a closure core with that as well. So let me add these back in. Easy. Yeah, I know. Like that's honestly switching Jank's like default literal types to C++ types seems like it wasn't that bad. Hey, Cobalt Ethan. Hope you're doing great. Is the default integral type for C++ assigned 32-bit integer? Yes. Doing good? Nice. Glad to hear it. I'm doing well as well. It's warm here though. Not like France warm, but warm. It was 82 in my office last I looked. It was over 82, which is not, it's not particularly comfortable. Are you calling Cobalt? Cobalt isn't a language, right? It's COBOL. That's the language. Maybe there's actually one called Cobalt. You could almost boil water that. 82 degrees Fahrenheit. Could not almost boil water with that. Okay, so now we're actually compiling the core libs. Although it's taken a while. I wonder if that's gone into some like bad clang territory. We can try it out. Seems like it had a lot there, but yeah. All right, let's dig around. This is what you get from a phobic for saying easy. It's never that easy. Probably a quick fix though. All good, brother. All right, let's take a look, see where we are. So okay, so this is tagged. FFA. So this is our nan tag for pointers. And so this is our actual pointer. But we're saying that we're asserting that it's not a tagged pointer because we're constructing from a void pointer. Oh, was that the difference? Did I miss that? Let me do a diff. So not here. Here. Were we doing something with the pointer? Jinx would be a great name for a programming language. I like it. Jinx was a cool character too in Arcane. Yeah, I think that the as pointer is probably the difference here. And that was around 150. Yes. So I fucked up a little. We need this guy. All right, I don't actually need this. Pretty sure. Feel like you have to make a programming language now just to use the name? Go for it. Jinx can be whatever you want it to be. All right, so let's kill that, and then let's do it this way. I just want to see what happens. So the main thing is that when we just blindly convert all of the literals in jank to be native types, we actually introduce a lot of code bloat. Because every time we're going to be doing like a print line 0 or a get 0 or a true or a false, the jank compiler is then going to say, okay, so we have this native value, and in this particular call position or in this particular whatever position that we're in, we need a boxed object. And so the jank compiler is going to be inserting a whole ton of implicit trait conversions. That's going to be our main problem here. This is an interesting one. So line 492 of core.jank. Yeah. So in this case, both branches of this if return different types. So this guy is returning a C string, and this guy is returning a JTL immutable string. Now the problem is, also we should make this const. We should make our C string type const. The problem is these are actually compatible types because you can construct a JTL immutable string from a C string. So the if analysis could actually support this. We just don't right now. Interpretable language, compilable to LVMIR, direct linking against C, C++, and Rust. Declarative GUI language independent of the underlying GUI framework. Something, garbage collector, but with manual memory management, a borrow checker. Yeah. You can do all that if you want. Exactly. Also, something like easy cross compilation. Also, completely memory safe. Yeah, so we have, I think we could work around this for sure, but I think we probably just want to add analysis support here for compatible if branches, which is a bit of a side quest to be able to support this. But I like it. Memory safe to the garbage collector. Well, there's a lot more that goes into memory safety than garbage collection. Like you need to make sure, for example, that things can't be used after they're freed. You need to make sure that uninitialized memory can't be read. You need to make sure that you can't overrun buffers. Oh, right. You did have a borrow checker. Yeah. Do you have escape hatches, though? Because Rust has a borrow checker and it has escape hatches, which then can lead to unsafe memory unsafety. Getting all the C++ fanboys over with unique pointers. Yeah, jank as a GC. We'll see how the C++ folks feel about that. But good luck making a dynamically typed polymorphic language like Clojure without a GC. I started with reference counting. Wasn't good. In terms of perf, wasn't good. Funny thing with Clojure is that you get a functional language based on object-oriented backend, which violates all the functional programming principles in the best way possible. That is true. The entire Clojure runtime is basically just is just a God object with a bunch of synchronized immutable state. That's like, there's in the Clojure JVM compiler runtime, there's a rt.java, there's a runtime.java, or retweet. And it's just this mega file that has so much functionality and so much state, mutable state in it. And everything's built on that. You might not crash your car if you have a fast code. What if you have a fast seatbelt? Think about it. Think about it. I'm going to step away for the restroom. I'll be right back. Every car is faster without a seatbelt due to the weight reduction. Nah, man. Everyone wear your damn seatbelts. Fucking jokers. Let's see. Why didn't Ruby take off, man? Ruby is pretty big. Wasn't GitHub made in Ruby originally anyway? I don't know what it's in these days. No clue? Yeah, pretty sure. Analyze if thought so too. Yeah. Hey, Johnny. How's it going, man? I hope you're doing great today, man. If one of the branches has a native type, we need to match one of these scenarios. The other branch has the same native type, or the other branch has an object type and the native branch is trait convertible. See, there's a third type here, or there's a third branch here that we're not, we don't even have listed, that needs to be supported. And that's exactly what we ran into here. So the other case is the other branch has a native type, and now what if they both can convert to each other? Then we just choose one. I really don't think it matters. What if it's primitive and trait convertible? That's fine. We have precedence here. Because we don't like trait conversion is fallback. The other branch has a native type, and the two native types are compatible. What's the topic of the day? Well, Johnny, what we're doing is we're right in the middle of making it so that when we do literals in jank, so that includes integer literals and floating point literals and bool literals and string literals, those four. When we do literals in jank, we're making it so that those literals have native types rather than being boxed objects by default. So how it used to be was like this 0 here is a boxed jank object. And then we would do trait conversion and everything if you try to use it in a native way. And then if you wanted to get the native value, you would do the CPP reader macro. But we're tossing all that and we're saying, nope, let's start with native values. And the only reason we didn't do this before was just because we haven't had like really good C++ interop for that long. And now that we have it, we can go back and change our literals to be native values. Is jank interoperable with CPP? And yes, if that's true for C as well. Foodude42, yeah, for sure. So C++ has Foodude. Jank has world-class C++ interop. It has better C++ interop than any other language. And it has as good of C interop as C++ has. Which is pretty good. jank best at C++, noted. Yeah. So there's, you'll find other languages that have C++ interop like D and Swift. And both of those have pretty good C++ interop. But you'll run into issues with those around virtual function, invocations, and throwing and catching of exceptions, and instantiation of templates. And then there are issues around like operators and overloading, and there's a bunch of like hairy stuff when it gets to into the weeds of C++, and jank does all of that, and D and Swift don't. What about Carbon? I don't know. Was Carbon made to be a complete superset of C++? Okay, well, this is absolutely not C++ at all to start with. So bidirectional interoperability with C++. Yes. So based on the goals here, Carbon should end up with C++ interop that is on par with Janks. I don't actually know how it looks in practice. Do you have memory safety features in Jank? Or is it GC until you do C++ interrupt? Yeah, so everything in Jank is garbage collected until you start doing C++ interrupt. So everything in Jank is closure until you start doing C++ interop, right? So Jank is just taking the closure world and the C++ world and then mashing them together. And so everything in the closure land is garbage collected, and you don't need to worry about lifetimes at all. And then in C++ land, you have all of C++, and so you have stack allocated values, and we do have RAII. So the scope of C++ values is bound to the scope of the let in which they were defined, or the function in which they were defined, and we run destructors as needed. But you're still able to do bad things in C++, on the C++ side of Jank. So if you want to grab the address of some stack allocated value and return that as a pointer, then Jank is going to let you do that, because C++ is going to let you do that. So to get around that, I do intend to have the option for building your Jank programs on the fill C runtime, Kubiman. I think that would allow. This is basically what Andrew Kelly just announced. He wants to do a Zig as well. So that would allow people to, at a penalty of runtime performance, have complete memory safety. I think that's an interesting avenue. Beyond that, I don't have any near term or midterm plans for like addressing further memory safety on top of C++. Use FilC as well. Nice. Okay, cool. Yeah, I think that makes a lot of sense. Obviously, there should be a YOLO C option for people who just want the perf and don't want to worry about the memory safety. I think depending on the inputs that you're working with and how who your program is exposed to and the memory profile that you require, going with the YOLO C might be a good option. But if you're like, okay, I really can't trust my inputs and this thing needs to be network facing and can't deal with any possibilities of remote code execution, anything like that, and you're willing to accept the performance hit, then running on a FilC runtime makes a lot of sense. So I think that should definitely be an option. You want to implement a borrow checker, but until don't trust yourself. So what I will say is long term, and so I said short term, midterm, I don't have anything, but long term, Kuviman, I'm quite interested in Carp. Carp is a Clojure-like language. It's not actually a Clojure dialect, but it's a Clojure-like language that has a linear type system, linear/affine type system. And that's not quite a borrow checker, like Rust's borrow checker is kind of like affine type system plus, but I think that going with that sort of type system around consuming values and borrowing values makes a lot of sense, and I think could be a really good way to manage lifetimes in a way that is not as complex as Rust's borrow checker. I want both linear affine borrowing. I want all of it. Give me all of it. Yeah. Is Clojure transpiled to C implemented in Rust? Carp is implemented in Haskell. I don't think static type systems are that interesting, but having tools for proving things about your program. So Fromophobic, when we're talking about linear affine type systems, it's odd that these are called type systems, but this sort of thing in particular is actually not really a type system. It's like a lifetime system. So you don't actually have to have statically typed data, for example, in order to be able to use a linear type system for lifetimes in your program. That's my understanding. So I think you could still have polymorphic, dynamically typed Clojure code, and then have some sort of linear type system on top of that manages the borrowing and consumption of values. But yeah, that's a long-term thing. Not worried about it yet. Static type system is exactly proving certain aspects of your program. Yes, it is. By definition. Okay, so let's handle this second case here. So this condition is already kind of a mess. Are we going to mess it even further up? So if the types are not the same and the then is not an object. Okay, so this is for our error. So basically we're ruling out errors here. Okay, so in that case, all we need is additional check. So autoconst is compatible, let's say, compatible. And so what I would just want to say is like cpp-util is implicitly convertible. And so what we'll do is we'll do our then type and our else type. And then we'll do an or, and then we'll do the same dealio, but we'll do our else type and our then type. And I'm off screen now, so I can't actually see this anymore. So else and then, there we go. And then we'll say, and it's not is compatible. Backpipe, just subscribe to Prime. Thanks, man. Hope you're doing great. Appreciate the Prime. Okay, so what this means now is that if we compile this, that our previous situation should not actually be an error. And I know we're on a little bit of a side quest here, but this is still a good thing. I think the flexibility of the type system for ifs is important, because I think it's the sort of thing that's really just going to be a pain in the ass for people if it's too rigid. And we're already more rigid than C++ is. That is, like trying to make some things a little saner. C++ obviously has a lot of history, a lot of baggage. So I think maybe we'll cancel this, and then I'm just going to try to run this here. So that failed after a minute last time. I think that all of those conversions really blowing up the code generated, the generated code size. So yeah, we'll deal with that. We'll deal with that next, once we get everything working. But we should get to a point where anyway it works, and then we can deal with getting rid of all of those extra conversions. Because basically what we want is, if you do something like a print line 0, we don't want to get a native integer and then convert that to a boxed integer at the call site. Instead, we just want to detect like, oh, that thing is being used as a jank integer and not a C++ integer. And so we should just lift that as a, we should specifically lift that as a jank integer. And so right now, what we did was we had only lifted jank objects, and then we changed all of those lifted jank objects to be lifted C++ values. And what we really want is to have both. And so that way, if we're using it as a jank object, we should just lift it as a jank object, code gen it as a jank object. If we're using it as a C++ value, then we should lift it as a C++ value, code gen it as a C++ value. And then if we're using it as both, which is also possible, then we should use it as both. And we should code gen it as both. How long is a minute? I don't know. Was true of every bug caught in the field. It passed the type checker and it passed all tests. Yeah, how many tests were there? And also like how well were types being used? You know, there was that whole fuck, what was that? Was it a Mars rover thing? With the unit, some space vehicle had units messed up, and C++ made a big deal about this because they're saying, okay, well, if you encode the units in the type system, then if you try to add, you know, like if you try to add incompatible units, that's a type error, you know. That's one of Rich's most famous quotes. You really like that one? Yeah, I think it's a straw man argument. I'm not a big fan of that one. Because it implies that a good type system is being used, and that and then it's being used in a type-rich way. Yeah, I'm trying to put together my thoughts on that one. It's well known that I disagree with Rich on type systems. I have the very first conj I went to, I got in discussion with Rich about types. And we very much disagreed. But his main point was like, what are you trying to solve? This is what he said to me is like, what are you trying to solve with types? And I said correctness, documentation, and performance. Those are the three things, you know, I'm trying to solve with static types. And he wasn't satisfied with that. He's like, yeah, but like how do you know that static types are going to improve any of those things? And I said, well, having static types like improves documentation by there being types there for people to see what the fuck shape the data should be in. And the types improve correctness by asserting more statically, you know, at compile time. And they improve performance by giving the compiler access to more type information so that it can generate better code. What more do you want? And I still think that I would still answer it. I mean, maybe I need to present the argument in a better way, but I still think that those three facets are still the same answer. Nobody wants to write tests for everything. Yeah, that's true. Nobody also wants to wait this fucking long. What's going on here? Strong type system solves a lot of unit tests as well. Well, the thing is that unit tests are pretty useless. I don't like writing unit tests at all. I think that I'm a big fan of tests, but people, oh, it's so frustrating how a lot of people I've worked with, like they think of testing as unit testing, and they actually just say unit testing when they mean testing. They don't actually distinguish between like the different types of testing. And I would say like, no, unit testing is not a good indication that you're, yeah, Kuiman, exactly, man. So unit tests are not an indication that your program works at all, at all. But if you have, integration tests or end-to-end tests, functional tests, basically you want to test your software as though your user is using your software. You want to make sure that your tests actually give you confidence that your product works. And if that's not the majority of your tests, then you're doing it wrong. And I've spoken to, like, I was actually chatting with one of my mentees about this, and I said, like, the way that it should work is you have the bulk of your tests, and this is the way that it is with jank. The bulk of your tests, vast majority, should be tests that actually invoke your program with expected inputs and unexpected inputs and verify that the thing you get, the behavior is correct. That's just testing your actual product. And then sure, in some cases you'll have some functions that are pretty tough logically, and maybe you want to unit test those. So we do have some unit tests for some things, just to make sure that those are sort of fundamental systems that I want to make sure that those work. But it's like, I mean, that's less than 5% of the tests is the unit tests. And one of my mentees was saying that where he works at Google, they have a testing pyramid. And it is the exact opposite of what I said, which is the bottom of the pyramid. The largest part of it is all unit tests. And then as you move toward the top, you get toward the end-to-end tests. And it just blows my mind because it's literally backward. All right, I don't know what's going on with all this thing. But I'm just gonna leave it going because I'm curious, and then we're gonna work on the fixing the code gen. So in order to fix the code gen, we need to visualize what the problem is. Let's do that. Because this is a problem. Like there's no reason it should take this long. It doesn't normally take this long. And it's possible that all of that code bloat is doing this, but seems unlikely. I think it's something else. Okay, so right. Right. Okay, so why do we have all of these? Why did you choose internal fixed-arity callable objects up to 10? Well, I don't see a good reason that it needs to go any higher. I mean, at some point you have to pack the args, and all of those arities end up with more and more code bloat, because each of those individual arities, when you handle the arg packing, has a particular if branch or switch branch that has to deal with the packing of that. And I got to 10 and I was just like, I don't want to do another 10. So yeah, we do 10, and then the 11th is the special list parameter, which is here's 10 fixed args, and then packing the 11th. Someone's going to come out with a programming language that does 11. The thing is, it doesn't matter, you know, like this is the sort of thing that jank devs aren't even going to know about, because like the program, you know, like any variadic function can still take in any number of arguments. Yeah, it's only the number of fixed parameters that matters. Can you define a jank function with 11 plus fixed arguments? No. No, I got you, fromophobic. No. So if you want to do 11 plus fixed parameters, you can't. You'll get a very helpful error explaining the problem. I'll show you. Let's do it. So let's do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. You know, it's actually really difficult to count while also correctly typing the alphabet. I don't know if you've ever tried that before. Yeah. So this function has too many parameters. The max is 10. We should actually, we should do better here. We should also call out that if you need to take in more, then you should just use a variadic function. Oh, look, there's a to-do here. All right, this guy's just, it's been 15 minutes. I'm done with that. Shapeless zone. Okay, so we're not entirely done handling this case. So I actually, before we move on, I just want to make sure that we do that. So here, if we do if doesn't matter, and then this, and then here we have a string that we return like that. This will give us the okay. So that works, but if we do it the other way around, then that ends up being a problem. Yeah. So we need to select the right type. Select most native type. That's going to give us the most native type, but we need to handle both cases being native, and then which one to choose then. Yeah, so here we end up doing a little on follow-on check. I think we probably want another follow-on check here. So if they're both not objects, then we need to find which one. So if and then what's the order here? Is it to from? You jump to that, please. From to. So if we can convert from this to other, oh, now it goes, thank you. Then return other type. Otherwise return chosen type. So here we're doing native literals. Just making a note to myself to add tests for that. No viable conversion. Oh yeah, I'm returning there, and I shouldn't be returning. I should be assigning chosen type is equal to other type. And Let's do that. Mm. Yeah, LSP for this particular file is pretty awful because it's 5,600 lines of C++, and it has a lot of includes, including Clang includes, and it's just too much. It's too much for like Clang LSP to handle in real time. I could split it up into separate translation units, but most of them are all going to require the same amount of dependencies, and so it'll actually slow down compilation of jank. Although it would make editing faster. Cool. So now we handle that case, and we handle this case. And so for both of those, we make a standard string. Nice. Cool. Yeah, so we still need to test for that, but that's pretty nice. So basically what we did here is in this branch, the branch is returning a native value here, which is a standard string. But this other, well, the if is evaluating to a standard string. Now the then branch of the if is returning the standard string, and then the else branch of the if is returning a C string, which in this case is an empty C string. Now we've updated our analysis to detect this case and say, since these two types are compatible in the sense that you can construct a standard string with a C string, then we end up choosing standard string as the result of this if, regardless of the order. And so even if you put the C string first, we're still going to say, okay, well, you can't construct a C string from a standard string, but you can construct a standard string from a C string, and so we end up choosing standard string as the type here. So that's nice, but we still need to, let's see, I'm going to need to combine these. Okay. So side quest complete. Now we're back into dealing with this. So let me bring that back in. So here we have this literal that's going to be an int, and then we're calling a closure function with it. And so we're going to need to box that. And so what we'll end up doing is we have this here, v2 is our int, and then we end up boxing it right here. So we say into object, and we get v3, and then we deref our var for foo, and then we call that. And so we can see this in the IR where we have our literal, which is an int, and then we have an into object, which boxes that int into an object. So what we really want to do is remove this so that we can, when we're using literals directly with closure functions, we can just use closure literals, and when we're using literals directly with C++ functions, we can use C++ literals. How do we want to do this, though? So one option is that we do this as a separate pass, so that we just generate the C++ literals and the conversions. And then we have a pass that looks for conversions on C++ literals and then changes those into closure literals. But another way is that we keep track of this earlier than that. We could keep track of this Why do I only stream once a week? I think it just boils down to like, I feel like most of my work is spent just sitting and thinking and not doing a lot of coding. And so I try to specifically choose tasks for the stream that I know are going to be sort of more active in terms of me just writing code. And so part of that was like, okay, so I'll stream less, so that so I don't need to worry about the tasks I need to choose, because I generally try to focus on the most important tasks, but the most important tasks aren't always like very interesting tasks. So that's part of it. The other part of it is that streaming is exhausting, because like you have to just be on it for the entire time. I do like 3 or 4 hours, which is not much compared to a lot of other people. But by the end of the stream, I'm just like, my brain is shot. Maybe that's just old man syndrome. But how people do that, like every other day or even every day, is just crazy, So yeah, I mean, I have considered doing it more than once a day, but But yeah, it's a lot. How often do you stream, Kubiman? Also, hey Moon Pie Dumplings, hope you're doing great. I thought sometimes I should do more thinking instead of coding since no one understands the code anyway. Yeah, I mean, talking through the process is good, but also like a lot of the, I try not to do this on stream because I try to choose tasks on stream that I'm like going to be able to just crank through, and then we're all going to feel good at the end of the stream because we started on something and we finished it. But even then I still end up, for a lot of my streams at the end of the stream, I'm just like, yeah, okay, I'm going to have to look into this because I don't know what's going on. But yeah, I feel like a lot of tasks are just quite exploratory where I don't know exactly how I'm going to handle it yet. And then I'll try something that doesn't quite pan out. You stream almost every day, alternating coding and gaming on your alt channel. Man, yeah, I find that so impressive. Like I work a lot. I work basically I work basically 7 days a week, to try to, cause I'm just trying to get jank done, but to stream every day feels like so much more to me. Maybe I'm just putting too much weight into it, and I should worry less about the stream and how interesting it is and everything like that. You don't feel exhausted while you stream? Hard to do things outside the stream, I see. How can I code? I don't have people watching me. Yeah, I don't know. How long have you been streaming though, Koviman? Oh. If you're not streaming, you watch the stream. I see. Yeah, I don't watch that many streams. Obviously, like I'll hop into yours or I'll hop into Janet Cars, or some other like compiler devs. But I don't go in for the code either. I go in just to say hi and support the streamers I like. Because as soon as I start thinking about someone else's code, then I lose everything that's in my mind. Which is why I totally get it if you guys just don't care about the code that I'm talking about, because you have your own stuff going on. That's understandable. But yeah, I don't know. You don't watch closely? Yeah. Yeah. Maybe the simple answer, Kuvi, is just that I'm lazy for why I don't stream more. Because I definitely could. But I'm also a lazy motherfucker. I am. right, we're talking about passes. How are we doing this? Could have a pass to detect the boxing of literals. But we could also detect it earlier on. I think detecting it during analysis would be... It might be tough. If you get every stream into structured plan thing, then it's better, I suppose. Especially if you later edit into a YouTube. I don't edit onto YouTube. I just click export to YouTube. And then I just export the whole thing. And I don't expect anybody to watch a 4-hour video on YouTube of me struggling through compiler problems. But some people asked to get it on YouTube, so I put it on there. But also far too lazy to edit. I guess it all just boils down to laziness. Yeah, we have implicit conversions. And we do an into object. So we could check if that is a literal. Hey, Eric. How's it going, man? Ah, Eric. It's been going well. I remember you wanted me to take a look at an interview, didn't you? Do you have a link to that again? If you do, I'll fill up my water right now, and then I'll take a look. Since I said I'd do that a couple weeks ago, and then I forgot. Yeah, let me go fill up my water. I'll be right back. Where was that link? Oh, there it is. All right, I gotta try to get there from inside of my nest. That should get me there. But I'd be interested for your weigh in on the Zig drama. You mean the Zig Phil C drama? Eric, or something else? Also, is it Eric or is it Arik? What zig drama? Oh man. Yeah, Andrew's falling out with Bun. Eric is fine. Oh, fine. I'm reading into this though. Fine is not correct. There's Phil C drama. Oh man. Well, yeah. So there's, I actually put a link to this in the jank channel on Slack recently, but there was a post about, I guess there was the whole like my thoughts on the Bun rewrite, where Andrew Kelly basically rips the Bun team a new asshole. And says how awful their code is. But then there was the memory safe thing. Where is the I thought this was a very new thing I just saw on Hacker News. Why is it not showing up here? I should just be memory safe. This is it. Yeah, I probably did pass it. Yeah, it's this one. You're right. So anyway, there was this 2 days ago. Yeah. And there are people saying that Andrew is doing a sort of a knee-jerk reaction to Bun rewriting their Zig code into Rust by adding a Phil C backend for Zig, and then people are shitting on Phil Peaslow and Andrew about like what memory safe means and everything like that. And I've seen on Twitter there are a bunch of people who are saying like that Phil C is not memory safe compared to Rust, and that it's oh yeah, this is all an extension of the Bun rewrite drama. My simple way on it is this. My simple way in on it is this. I think that the Phil C runtime for Zig is cool. I think it makes a lot of sense. Zig is intended to be a superset of C, or like a replacement for C, not a superset, but a replacement for C. And Phil C is a really exciting memory safe runtime for C. So this is an optional Zig backend that nobody has to use, and that's that. Like it's an optional Zig backend that people will be able to use to get a completely memory safe Zig application at the cost of some runtime performance. And if other people don't want to use that and keep doing Zig the way that they've been zigging, then great. Good for them. So I think that the people who are saying that Phil C is not actually memory safe compared to Rust are misled, because my understanding also is that Phil C is more memory safe than Rust, because it's an all-around complete solution. And so it's not It's not a solution that operates on the language level. It's a solution that operates on the platform level. And so being able to detect undefined behavior from, or just lack of memory safety in general from all of your code, as well as all of your dependency code, that doesn't have to be a language feature. I think that Phil in particular, Phil Pieslow is identifying and putting the legwork in to show that you don't need really complex languages like C++, or like Rust is what I meant to say, like Rust, in order to accomplish memory safety. And that even if you get a really complex language like Rust, you don't actually get complete memory safety. But if you change this at a platform level, then you can. So I really like what Phil Pieslow's doing. I really like what that this is going to be an option in Zig. There are people complaining that it doesn't match the Zig philosophy because it has some hidden allocations that are necessary for some Phil C tracking shit. I'm not concerned about it. If Andrew's not concerned about it, then people should just accept it. If they don't want to use it, they don't have to use it. If they want to fork Zig from before Phil C was added as an optional backend, then they can do that. That's it. Jank will be hopefully adding Phil C as an optional runtime as well, and I imagine that I don't imagine that we'll have all the drama that there's been around this. Let me catch up on these messages, because that was a little bit of a ramble. You're welcome, Foo Dude. I don't know what you mean about Jank documentary. You probably mean the Closure documentary, in which Jank was not featured. But then again, neither were like any other dialects. They just focused on Closure JVM for the most part. Maybe Closure script, but they didn't get into like Babashka or Closure Dart or anything like that. Yeah. If you ignored 99% of the commenters on the issue and focus only on people's opinions that matter, Andrew and Phil. Yeah, the funny thing was, I remember that, because I actually read a lot of this. At one point, a lot of people are chiming in, and then Andrew's just like, can all of you just stop? Because your opinion doesn't matter. Yeah, so he's like, if you want to comment on this thread, please either have your open source Zig projects visible or be Phil Pieslow. Otherwise, this is not for you, which is quite spicy. But you have to think about this from the perspective of Andrew Kelly, how does it feel to have just so many people shitting on every decision that you make? It doesn't feel good. I've not been there, and I don't really want to be there. But it's got to be very difficult. And so he's trying to do something that he thinks is going to be really interesting to people. He's making it an optional thing that they can opt into. And then people are just like, oh, this is violating the philosophy of Zig, and this is not good, and we don't want this. And he's just like, it's an optional thing. Like, it's chill out, you know, like having everybody pile on is not helpful. So I, like, you know, if this were me, I wouldn't have said it like this. I'm not Andrew, you know, I'm me. I would have used different words, but I definitely would have wanted to convey the same thing, which is, it's not helpful for all of you to pile on right now. This is the direction that we're going. It's going to be an optional thing for you to use. And if you don't ever want to use it, you don't have to. You know, it's not going to affect your existing Zig applications. Okay. I hope that was you got what you wanted out of that, Eric. Yeah, there was this interview about with Mitchell Hashimoto about the work that he's doing with Ghost TTY and Zig. I have skimmed a lot of this, and there was not much. There was honestly not much I had to say. So, like, you know, we learn about his history in liking terminals. So he says he doesn't want to push. He doesn't want to, like, move everything into terminals and keep building them as reactive applications. But that they're a special part of our workflows. And, like, this is all very, like, non-drama stuff. Not too interesting. I'm very public. This is a good line about open source maintainers having zero obligations to users. This is Rich Hickey's Open Source Not About You, right? Which if you haven't read that, then you should go read it. You can just search Open Source is Not About You, and then there's a gist. Why is this gist by oh, here you go, Rich Hickey. This is the one. This is a good one, but it basically boils down to this same sort of sentiment. But yeah, he's saying, like, some days I wake up and I focus on other people's problems, and some days I wake up, I don't read a single issue, and I just work, and I do this as well. Like Mondays, I wake up and I clear out all of the issues and pull requests and everything like that kind of built up throughout the end of the week and through the weekend. And then as I get through the week and issues and PR start coming in and discussions, and I'm just like, I'm trying to focus on my thing, I don't want to work on that right now, I'll just ignore that. So if you want to get quick responses from me, then your best bet is to, like, get your thing submitted before Monday morning. And then Monday morning I'll get to it. There's a chance I'll get to it before that as well, but there's also a chance it'll be pushed until the next Monday morning. If all I did was pick through user issues every day, you get stable, stagnant software. And who wants that? Stable, reliable, stagnant. It's not full of new, fancy, ring-a-ding features all the time. this is kind of what Clojure devs want, right? Like we kind of pride ourselves on stable, stagnant software. A little bit. I switched to Brave search after learning DuckDuckGo is just a Bing wrapper. Well, you could be a Bing wrapper with different privacy policies, you know. DuckDuckGo has some nice features on its own. Like they have the bang syntax in DuckDuckGo is super fucking cool. Like I just search string bang CPP, and that gets me to CPP reference. Or if I want to search like let's see, everything everywhere, bang RT to get to Rotten Tomatoes, you know. Like that's super helpful without having to type like site : and then whatever. Hey Cogwell. Yeah, Bang W for Wikipedia, ArchWiki. Yep. Bang YT for YouTube. Are you happy with today's tech stacks? They're okay. Yeah, pretty much. Yeah, I do start page as well. Especially DuckDuckGo, the biggest failure. So I use DuckDuckGo for all my searches. I use Firefox for all my browsing. Only reason I have Chromium here is because I'm in a nested window manager. And if I try to open Firefox here, it connects to the to the other Firefox process that I have running outside of my nested window manager. But what was I going to say? Oh, right. But the biggest issue where DuckDuckGo fails is with syntax. And so, for example, if you want to search like Clang, WL, WB static. I think it's WL. So you search this on its own, right? And you just get like, oh, Clang, right? It's completely ignored this like the bulk of what I've just typed here. So you're like, okay, fine. Let me put that in quotes. What do you get? You get absolutely nothing, right? And so then if you bang that to this to start page, now you actually get useful responses that contain exactly this thing. Yeah, the minus means exclude, sure, but like it's in fucking quotes, you know? Quotes mean literally this, which should override the minus, as it does in start page. And so whenever I'm searching like flags, I have to bang SP to get me to start page. Aside from that, I think DuckDuckGo gives me good results. Why nesting window managers? So yeah, I use i3, and I wanted to, for the stream, I wanted to have something that doesn't expose my global window manager that has like all of my other windows open on it, you know, like my Signal window and my email and everything like that. And I have like so much muscle memory, procrastination muscle memory of like quickly jumping to other workspaces like, oh, I'm compiling, let me quickly check, my email, or let me quickly jump over to IRC or Signal or whatever. And so I didn't want to have to close all those applications because I still have them open. But I didn't want to jump to those. And so instead I have the nested window manager. So that way, when I'm in this window manager, if I try to jump to workspace 7, which is where my chat is, or workspace 9, which is where my email is, it just doesn't go anywhere because I have those unbound inside of the nested window manager. But I think, yeah, in general, Eric, for this one, I don't have any like spicy input. I don't have like, I agree with some of the mentality for open source maintenance, and aside from that, it's all just like, yeah. This is probably the one where I don't know. I think I'm much more conservative when it comes to AI. Leave it at that. Leave it at that. Hey Stan, growing interest in programming front end. Should I learn coding or I don't know, man. I like asking a random streamer for career advice, or just life decision advice is quite the gamble. I don't know. I just don't know what the fuck is going on with the industry. So I don't know. I don't know if you should. I don't know if you shouldn't. I think if you enjoy it, then and you have the ability to do what you enjoy, then that sounds pretty good. You quite like it. If you like it, then you could probably make a living out of it. It may not look how it looked for the past 20 years before it, but depends on what your other options are. You should tell everyone to start learning jank if they want to be successful. We don't even have like the jank docs right now assume Clojure. Like we don't have like intro material for learning jank. But yeah, Stan, it's I got into coding because it was something that I loved doing. I think a lot of people got into coding because it was something they loved doing. And if that's the case for you, then it doesn't mean you have to do it for work. It could just be something that you do as a hobby. There are a lot of people, for For thousands of years, there have been people who have hobbies that they enjoy, and then the work that they do in order to feed themselves and their family. That is a perfectly fine way to live. Doing what you love for work carries the risk of ruining the thing that you love. But it also carries the possible benefit of being able to do the thing that you love every day. And that is, only you can make those decisions. You're going to give it a try? All right. I wish you the best of luck with that. I think you can make it work. So back to code. Back to code. We've done our Zig drama. Appreciate the follow, Stan. We've done our Zig drama, which is overblown, and I'm on Phil's and Andrew's side for that. We were trying to improve the code gen for the case where we have a literal, and then we need to box that in order to get it into a call. And so ideally we want to remove the box by just having a literal in the first place. We could detect this with another IR pass, but we could also detect it during analysis. And in analysis, right here is where we would detect it, which is when we try to apply implicit conversions, and we detect that we need to do an into object conversion. In that case, we could check if the expression is a primitive literal expression, and if it is, then we could generate some other type of expression, or we could note in the primitive literal expression that it has both, or that it has a boxed usage. I'm not quite sure how we want to do that yet. Maybe we want a different literal AST node type. So if we have basically if we had a closure literal AST node and then we had a CPP literal AST node, then what we could do is, by default, when we run into a numeric or a string literal, we create a CPP literal AST node. And then if we need to do an implicit conversion of such a CPP literal, then instead we just create a closure literal expression. That would address it on the AST side, so that we never end up generating those conversions. But then we would still need to update our code gen to be able to support, our IR gen and our code gen to be able to support both of the different literal types. So right now we have a primitive literal AST node. We have a literal IR instruction. And then we track the lifted constants inside of the IR module. Those are the three things that we would probably need to change. So if we add a CPP literal AST expression, let me write this down. So we have a AST primitive literal. We have a literal instruction, and then so we'll do a CPP literal, and we'll do a CPP literal. And then we support both types of lifted constants. I think that this would work. And I'd rather do this than have an IR pass. Just because having to do all those IR passes for every single function, those build up. And I'm not opposed to adding passes to do helpful work for things that we don't have the knowledge of when we're doing analysis or when we're doing IR gen. Especially things that need to take a look at the whole function IR in order, like the whole control flow graph in order to put things together. No problem adding passes for that, but this is the sort of thing where we can have all this information during analysis. Let's do it. So I'm going to add a CPP literal type. I'm going to add a CPP literal instruction to IR, and then we're going to update our IR processor as well as our code gen to track both types of constants. So I'll take the primitive literal AST expression and I will yoink that into a CPP literal. This takes in data. I think we should just take in the type as well. Because we talked about how the widening logic for the type is quite involved. I guess we could put that in a helper. Yeah, that's fine. No, we'll have that in a helper. So we can do that. And then expression, so we have a enum for all of the expression types. We just need to add a new one here. And okay, so there's CPP literal, and so the data that we keep track of is just a jank object. That's fine. none of this actually changes. So we mainly just have the separate type here. We do need to add there we go. Now, when we analyze primitive literal, we're going to need to construct, rather than always just constructing a primitive literal here, we're going to need to conditionally construct a CPP literal. And so we'll do that by getting the type of CPP util and then literal type O. And then we'll say if CPP util is any object. So if it's a boxed object, whoops. If it's a boxed object, then we'll return a primitive literal. Otherwise, we're going to return a CPP literal. Yeah. Okay, so that's that. That's the first part. Now we need to handle our new AST node in a bunch of different places. So for example, eval. Value. So let's see, what we were doing before is if the value is a keyword, then in turn, otherwise just return the value. Yeah, I'm just going to do that as well. And then we need visit literal okay. And then the only other one is IR processor. So we're gonna do okay. So we've added our AST node. We conditionally create it. We need to bring this in here. We've added it to visit. We've added it to evaluate. And now we've added it to IR generation. So now we, I think, are completely done with this first point, which is this. And so now we just need to do, the new IR instruction. In order to add the new IR instruction, we are going to add that here. So we're going to do something like a B. Actually, let's take a look at how we do a primitive literal. Yeah, so we do a literal here. We'll do a CPP literal. And this is the data. Okay, so now we need to go to our IR builder and also IR instruction. And so here we're going to have our literal. We're going to need to add a CPP literal. Literal. What? So this just takes in the so the literal here takes in the identifier for the value as well as the actual value object. I think that's what we want to do as well. Value object as well as identifier. Hey, Robusta. Welcome to the stream. Hope you're doing great. So I'm just going to yoink that. Wop. Instruction kind is CPP literal. Object value. Good and you? I'm good. Been having a good day, been having a good stream so far. And making progress. We're working on something that I've been wanting to do for months. And really hoping that we can just crank it out today, because that'll feel good. It's gonna feel good. So we have our CPP literal instruction now. And so we need to add this to a few places as well. So we'll have IR visit, and we need to add it here. And so value becomes literal, and value becomes literal, and okay. And then IR print as well, CPP value. And value becomes literal, and so we have a literal scope. No. What are we doing for what are we doing for literal? So we have literal, and then we just have value, and then we just do a 2 code string on that. Okay. Okay, so there's our instruction visit and print, and now the only other thing is value literal So we do a CPP literal here. I actually don't know if we need that. IR builder. So we're gonna do CPP value right here. We're gonna yoink whatever we do for literal. And then we're gonna search for this. So this is gonna be CPP literal. So we have a position, we have a value. Yeah, that's fine. Yeah, so here we're doing quite a bit of work. This is in the IR builder. And so we're doing work here to keep track of the literals that we have lifted, which is to say that when you access literals within a function, we will lift those up out of the function and we'll dedupe them. And when you have multiple functions inside of a module and you're doing whole AOT compilation for a module, we lift all of those literals up to the module level. So that way they're deduped across all of the functions that are in a module. And so we're going to end up doing the same thing for CPP literals. Okay, so... Yeah, so we're using the same literal code gen type function. I think that's a bit of a problem because the CPP literals should use that. Like we've updated that now to return native types for the literals. But for our normal literals, we actually still need to return boxed types. So we're actually going to need another function. We're going to need like a literal, I guess we have two now. We have literal type, we have literal code gen type. We're going to need like a literal type. Do we need 4 functions? Literal type and boxed literal type, literal code gen type and boxed literal code gen type. Either that or add a bool parameter. Yeah. Not, I don't know yet which one. Not going to worry about it yet though, because so our module has these lifted constants. We need to go into that and basically, whoops. We need to do a lifted CPP constants as well. And we don't actually need to do very equal with meta because none of our values are going to have meta. This is just a comparison function for the hash table. So we're hashing the object refs, but object refs can have the same hash while having different meta, and we need to treat those differently for normal constants. So when things have a hash collision, they then are compared, and then they're compared with this. They're compared with this particular function that also compares the meta. Very equal to with meta is a great name. Just because there's a C++ equal to, and then there is a very equal to, which is type equality as well. So because like an empty vector is equal to an empty list by default. But what we care about is for very equal to is that we also want the types to be equal. And so I didn't have a good name for that. I said this isn't a great name. And then we built upon that by saying very equal to also with meta. Naming can be tough. Okay, so we have our lifted CPP constants. And what we're going to do is, I'm just going to search for lifted constants. And so we're going to do lifted CPP constants, lifted CPP. All right, that's it for that. So we try to find it. If it is not found, then we munge, we in place, otherwise we grab it. And here we'll do a CPP literal. And we return if we need to. That all stays the same. That's the same, that's the same. Okay. And so the only other thing I think is that we jump back to our list. This is done. The only other thing is code gen, dealing with these constants in code gen. So we have lifted constants shows up 6 times. So at the namespace level, if we're compiling for a module, we end up looping through all of our constants. And we here again we do our literal code gen type. So we'll need to fix that. So we'll just loop through these guys as well. Now we were initializing them to jank null. All of these are going to be primitives, so we can just zero initialize them. That will be no problem. Cool, let's jump to the next usage of this. So here we're adding the lifted constants as GC roots. That's because they're boxed values that can point to GC allocated data. But for our integers and floats and bools and C strings, they won't. So we don't need to do that. And then here's where we initialize all of them in place. I think that we can initialize all of our C++ literals in place. We don't actually need a 2-step initialization for those. Let me do that right here. So we're going to do... That means in gen constant, we're going to need to know if we're generating a boxed constant or not. That's okay. So let's assume that gen constant takes bool const boxed. And so yeah, we'll need to swap this back as well. Won't worry about that yet. So what we had was for integers, So if we're not boxed, then we're just going to get the data. Otherwise, we'll do some boxing. Now we need to do the and then the last one would just be around the string. And so previously we were doing all this. And so here we'll say if we're not boxed, then give me this. All right. Now there was one other place that we were doing constant work, which was in this lift constant here. And we changed how this worked. Where is lift constant called from? It's called from literal. So we probably want to just undo those changes. Because I think for this type of lifting, there's actually nothing for us to do for normal. Yeah. Okay, so we'll... Where was that? I think that was right here. This might be easier to just grab this and check out. So right here is the problem. I think we just check that out. We also have, we have to fix this, literal type stuff. So we have a literal type and boxed literal type. There we go. So CodeGen type uses that here. And then because we added that parameter, that's also, we're going to be able to follow the, compiler errors through all of the usages. That's going to help us as well. Because then we're going to be able to decide in each of those usages if we want it to be boxed or not. So here it will say if is boxed. I was doing not boxed first for all the others. I'm a bit bothered by that. There we go. This is Boolean. I'm just going to yoink this else. And so here I'll say if not is boxed, and then I have a else yoinked, and then boolean becomes integer. And then the same thing, if not is boxed, and then real. Real. And then small real. And then the last one is string, which we're doing this C string type. And so this changes to persistent string ref. Okay. Also, this can't be static. That was going to be a fun bug, because we would have initialized that once and then never changed it. So whatever the first string was would have been the type that we get. Then every other string would have had the same type. Okay, that's gonna get us some fun errors that we can work through, and then that's gonna help us choose where we need to use all of those, where we need to add all those bools and which bools they should be. All right, so primitive literal here. So for this guy, we do want boxed. That's easy. And then analyze processor 3176. So this is primitive literal, so we we want false here. Hey Arun. Big fan of your work on jank. That's great, man. Welcome to the stream. How you doing today? CPP literal. False. Walking. Left your work last week, taking a break. Doing some closure stuff. Cool. That sounds chill. IR walk. Okay. Value literal. What sort of stuff are you building in Clojure? Walk references. So this is CPP literal. Building the web app, nice. And then that was rewrite. I know that was instruction. Out of line definition. Literal does not match. Okay. Name, type, location, object, value. Name. Right now it's pedestal. Some HTMX, hyperscript. Cool. I haven't jumped into HTMX at all yet because I just haven't been doing any web stuff. But I've been watching it from afar. What are your thoughts on that? How's it feel? All right, so CPP processor, literal type. Okay, so for this one, we do want boxed. And then literal code gen type. For this, we do want boxed. For this, we don't want boxed. Do and don't. You worked in enterprise where React is the default? Yeah. That's kind of like when I did web dev, it was all React as well with ClojureScript, which makes it a lot better. But still. Yeah, so we'll put value literal. It's amazing how much logic people put into front ends these days, and think that it's totally okay. It hurts my like minimal oriented brain. Like for Jank's blog, for example, I had to go out of my way to make it so that the syntax highlighting that we have for the code blocks is done like offline, you know, as we're building the actual page. Because the way that basically everyone does it is you have every single one of your viewers download highlight.js and then execute all that JavaScript and then dynamically update the DOM to fucking highlight the code. It's so ridiculous. It just blows my mind. 358. And this is for a persistent vector, so we'll do true here. 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 False here. True here. Is wholly unnecessary for most web apps. Yeah, for sure. Like you can, I mean, there are some great interactive applications where React is a great fit. That have a lot of rich, like data and interactions, the real-time updates, and I can see the appeal, but I don't think it should be the default for applications. You became more interested in Deno, tried switching that. Shadow CLJS is made for Node. Yeah. Yeah, getting something like Shadow working with other setups. When I was at EA, I built a closure script front end for a service that we had, and we later had to embed that closure script front end inside of another JavaScript application. And rather than using like standard module loading, they used some, man, I don't even remember what it was called. They used some like third-party module system. And Shadow had no way of generating code that used that module, you know, like that module's protocol system. And I was like, but like, why don't you just load like normal standard ES modules? And they're like, well, different browsers, you know, have different support for different things. And I'm like, yeah, but like every browser that your platform supports standard modules. And they're like, well, and so we had a really tough time trying to get our ClojureScript application into their thing. And then people are like pointing at ClojureScript and blaming that as the problem. And I'm like, well, sure, I guess if we had used like the same stack that you guys are using, this wouldn't have been a problem. But like, also, if you just use standard fucking ES modules, this wouldn't have been a problem. Yeah, really not a big fan of the JavaScript ecosystem. I'm happy to be back in like writing local software on a desktop for a desktop. It's lovely. It's amazing. I'm kicking myself trying to remember what that module system was called. Printing, we're crashing, presumably because this is nil. It's not. It's possible that we have something bad already. CPP literal doesn't have much going on. Yeah, I don't know why that would have an issue printing. What's builder.cpp? That's IR generator. Yeah, so we're in jank IR builder. This is the helper that we use for generating our IR. So the IR processor, which is this guy, is what walks the AST in order to build up our control flow graph. So the IR processor uses the IR builder in a similar sort of pattern that you would have like with LLVM IR, except this is for Jank's custom IR. But at some point, for some reason, why are we printing this anyway? I don't have the Jank print IR set. Why are we printing? 1821, good year. The fuck is this? What are we doing with this string builder? Why the fuck do we have this print here? Interesting. So we've had a print. I mean, this is not code I've just added. So this code that's been here, we've had code that does a print into a string builder and then just comments out the actual print to standard out. But every instruction is being printed into a string builder and then thrown away. I did not realize I had committed that. But still, it shouldn't crash. Still, it should not crash. But it crashes because we try to get qualified name. And there's something wrong with getting the qualified name of CBP literal print. I think that the problem here is that we can't get the qualified name. I think we just have to do this. Can we do that? I think this is I don't think this is a crash that's an issue on our end. I think it's a crash with the issue of how we're using Clang. And Clang is really picky about some of these things. So let's see. Ooh. Maybe it is an issue on our end, because what the fuck is this? Whoops. B1. Const 3. So it's not completely torn apart. It does seem to have relatively normal data in there. We have 3 format specifiers. We're passing in 3 things. I think that the printing is not the problem. But just to be safe, I wonder. I'm starting to suspect that there's something wrong with this this type, cling type that we have. Yeah, it's still crashing right away. Yeah, now we're crashing in the string builder. When we're trying to print as well. So 1820. 1820. Oh wait, this is the constructor of the string builder? Okay. Okay. So it's not our IR. What's our stack look like? Oh, there you go. There you go. That explains it. So in case that wasn't clear, what we're looking at actually is a Stack Overflow. But the Stack Overflow results in undefined behavior. Rather than a nice, helpful like JVM message saying that there's a Stack Overflow, we just start getting like a bunch of weird memory issues. But yeah, when you take a look at the stack and it's over 13,000 frames, then there's your problem. So the problem is that we're stuck. Yeah, there's an old pattern that I was using that I stopped using, but this code is still using. That can get into this case if you forget to add an overload, which we have done here, which we have forgotten to add CPP value. Yeah, so we don't have our CPP literal case here. And so we ended up in this loop. Let's take a look at what we were doing for this. Okay, so we were doing a lift constant for this. For the CPP literal, I really don't think that we need to. All we need to do is just generate the literal. Do we need to do a lift constant there? Maybe we don't even need to lift these. Because Clang will do all that lifting for us. I just don't know if it makes sense. Maybe we can get away without lifting them at all. So we want to grab our... What is this value after all? So we construct in our, we have a lifted literal name. Yeah, so this is because we're lifting. All right, I'm gonna fill up my water, use the restroom, and then we'll fix this. We're back with water. Stay hydrated, folks. New season. Okay. Let's... I think maybe we want to keep this. No, I don't think we want to keep this. How do we handle the lifting of these? This is for eval. Otherwise, we return the name. Right, eval. So we probably need Zibul here as well. Yeah, but do we? Yeah, that's fine. We'll do that. We'll try it. So I'm gonna negate this actually. So in this case, format stir, and then we return format stir. So here we're just going to return to code stir, and then we should have two uses of this. So right here true, and then right here false, and then lifted yes. Yeah, so we code gen constants differently depending on whether or not we're doing AOT compilation or not. And the main difference is if we're not doing AOT compilation, meaning that we are doing JIT compilation, we don't actually generate the code that allocates the constants. And the reason is that we already have those constants in memory. And so instead what we generate is the actual pointer address of that constant as it exists in memory, and then a cast to the correct type. And so that way we just use the constants as they are in memory, and we reference them by address. This allows us to avoid unnecessary allocations by generating, that we would have if we generated the code that allocated the constants as though it was starting from scratch. However, when we are doing AOT compilation, we are starting from scratch. And so we do need to allocate those constants. And so that's why we have separate code generation paths for that. Okay, cool. So we are no longer crashing, but now we get an interesting sort of error. So this says that CPP raw is expecting a string of C++ code. And it's like, oh yeah, right here, this has to be a string. We're probably doing a type check on this, and we're expecting to get back like a persistent string ref. But instead we're getting back a C string now. Let's take a look at the analysis for CPP raw. First and only argument must be a string of C++ code. Right. So we're expecting it to be a primitive literal right here. And that is not what it is anymore. It's instead a CPP literal. And so here, CPP literal. All right. Try this again. Well, no immediate failures. That's good. But we also had that issue last time where it was just running. We let it run for a long time and didn't finish. So we'll see if that is still a problem or if it's actually in the realm of like terminating properly. I think we have everything covered. But then again, it wouldn't be the first time I thought we had everything covered. And it turns out we did not. Easy. Oh, you're still here, fromophobic. Yeah. Now, 3 hours, 45 minutes in, dropping the easy is, it hits differently. It does hit differently. Yeah, this is still taking too long. Still taking too long. There's no way that this should affect the compilation time this much. Okay, so here's what we do. We open up core.jank and we just start commenting out entire chunks of it. So this should finish instantly. But it doesn't. Because that was only 500 lines. But we're struggling. We're doing something. Okay. Moving further up. Okay, so this does error. And okay, so we're erroring related to the const usage. Okay, so this is probably because we're not lifting our AOT constants properly. Let's take a look at. Okay, so we're still not loading here. So we should be able to do an example here where we're going to we don't have deafen because we don't have closure core yet. So let's just have a function like so that returns 2. Let's take a look. So we'll do a jank print ir, jank codegen of this. This runs fine. Okay, here's our function to convert it to an integer. Wait, this is not right. It shouldn't be converted to an integer. Want to rate your LinkedIn? Nah. I want to finish my compiler feature. I don't even want to go on LinkedIn for my profile, let alone someone else's. LinkedIn's a mess. This should not be the case, though. And also, why are we loading closure core? This is... I have it commented out here. When we're doing a run, we're doing a jank run. What's all this shit? Closure core foo? Wait, foo is what I'm defining right here. What is all this? Where's all this coming from? Converting closure core. Converting test.jank. What is all of this? That might be why this is taking so long. I think I don't fully see it yet, but we have a code path that's taking our native values. And so we just basically turned every integer, floating point value, Boolean string into a native value, right? I think that we have we have a code path that's taking our native values and wrapping them in functions. And so here, this is just closure core as a string being turned into an object and returned. This is just test.jank as a string being turned into an object and returned. This is just the integer 5 being turned into an object and returned. This is just the integer 1 being turned into an object and returned. And so closure core was taking so long to compile because we're taking like every single literal in there and generating a wrapper function for it that converts it into an object to return it. And then, so we're doing all of that work. We're generating, I mean, at that point it must have been several hundred functions. Why? CPP conversion. This has to be happening in eval. But CPP literal, so CPP conversion is right here. But we shouldn't have a conversion. We forgot the very first part. So we made it so that when we analyze the literals, we either get a primitive literal if it's something that we don't unbox, like a integer, float, bool, or string, or that we get a CPP literal if it's integer, float, bool, or string. But then the other part was that we would detect, and I even put a marker here in Vim to try to remind myself, but I still forgot, was that we would detect when we have a conversion into an object, and the expression is a CPP literal, that we would generate a literal instead. And we never did that. And we never did that. But we're gonna do that now. So here we say if expr kind is equal to expression kind CPP literal, then return a primitive literal expr. I think that's called frame. Yeah. And then we need to grab the... and so here we have CPP lit data. Oops, my bad. Nice. So here we get an error saying that we can't find NS because we successfully compiled Clojure Core, and then we tried to compile other things as well. But they were expecting that Clojure had provided the NS macro, and Clojure Core does not provide the NS macro when you only compile 75 lines of it. So let's try deleting all of this and then saving, and now actually compiling all of Clojure Core. Meanwhile, yes, and this is boxed. Yes. So our 2 here, because we're returning it from our function right here, we don't start with an int and then box it. We just do a small integer f. Yes. Whereas if we were to put it into a let and then do nothing with it, then it ends up being unboxed, right? So the difference is small integer ref here because it's boxed, and it just straight up 2 here because it's not. Okay. And then we get actual errors. We get actual errors here. Okay, so the character arrays. Okay, so we need to double check how our codegen looks for AOT compilation. Let's do this. We'll do 2 here. We'll do meow here, and oh, I'm gonna yoink these. I'm gonna put them into temp. I normally have a temp AOT. Do I have that? No, I don't. So let me open up a temp AOT.jank and put that in here. And then I'll just do a jank compile module path temp AOT. Yeah, so this should be very fast. So why is that also? Oh, because it's trying to load Clojure Core. So compile module is also trying to load Clojure Core right here. Right now I'm making my own color palette. Oh, that's cool. What sort of palette are you going for? Right now I'm spilling water on myself. brown and purple. Oh, that's, yeah, that's a good look. Jank on wild. That's a different stream from homophobic. That's for when money really comes a problem. Okay, yeah, for sure. So we're this is an annoying thing about C++, right? So for basically every type, when we do code gen, we can just do the type, and then we can do the name, right? And then we can do the curlies that initialize the value. Except for arrays. For arrays, you have to do the type of the element of the array, and then the name, and then the dimensions of the array in square brackets. And so that ends up being a real fun treat. The nice thing actually about our code gen for these literals though, is that we can just use auto. Because our type for the literals is going to match the same type as what C++ will use. So right here where we're doing this, auto const expr. Nice. This is coming together. This is going to be good. I'm feeling good about this. It's been a little bumpy, but I go through the bumps so that you guys don't have to. And honestly, like 4 hours to change the whole like primitive literal type system for jank, I'm all right with that. Okay, so that was very speedy. Now, why are we not putting in a value here though? We should be generating a value right here, right very here in this exact spot, because we're putting it in the wrong buffer. Because I copied some code. I will admit it. I copied the code. I copied that code from somewhere else, and it's parameterized on the buffer that it's supposed to be rendering to. It was copying to the footer buffer. I pasted it. I didn't change it. And so although we're currently supposed to be filling in the module header buffer, the way that I had it, it was filling in the footer buffer. That's my bad. I'll own that. All right, nice. So now that works. Let me do the same thing, but with IR and code gen enabled. So we end up with lifted nil. We end up with a string literal. We end up with a 2. We end up with a var for closure core / foo. So these are all of our lifted doodads. And then here we're just referencing 13, 14. That's our meow and our 2. And then we grab 15, which is our nil, and we return it. Fuck yeah. Now the real question is, does closure core compile? Not quite. Not quite. Okay. Oh, because for bools, we're not yet doing the correct code gen for those. Oh man, we're close. Chat, we're close. We are close. Okay. We need our gen constant right here. Okay. Yeah. So we need to say if is boxed. And so for this one, we're just going to generate warp. I keep typed data else if. Okay. All right. All right. Yeah, so if we were to open up temp AOT and we were to put I should have done this, but true, and then also 3.14, and then we were to compile that guy, then here's our true, there's our 3.14, there's our 2 and our meow. Those all look amazing. So, yeah, so we intelligently track whether or not a C++ literal is used in a C++ way or in a boxed way, and then we adapt accordingly. Now we should still see how this works for something that takes C++ values. Let's say something like toString and then 42. What happens? What do we get? Do we get things? Let's find out. Nice. So yeah, V6 is 25, 25 is 42, and then we just call toString on that. Nice. And so this, previously, this bit of code right here, line 6, where we call standard toString with 42, that code would have not compiled. That code will not compile on main because main 42 is a boxed jank object. And standard toString has a fuck ton of different overloads. And a bunch of them are trait convertible, right? So they have bools and they have floats and they have ints and they have different size ints. And they're all trait convertible. And so this would have failed on main, and it would have said this call is ambiguous. We can't do overload resolution. The call is ambiguous. None of the direct overload matches work. And then if you consider trait conversion, it's ambiguous. We have an error that says almost exactly that. But now it works. That's what we fixed. That's what we did today. That is what we did here today. Traits in C++? Oh yeah. C++ had traits before Rust existed. They're just not first class in the same way. Their traits are an idiom. They're a pattern in template metaprogramming. They're even called traits in C++. There's even a header called type traits in C++. type traits, CPP, bang CPP. Yep, since C++ 11. So traits are generally either predicates on types or they're transformations on types. So something like is same, is base of, is literal, type, is final, is aggregate. Those are predicates, but then you also have things like remove pointer, add pointer, remove CV, add CV. So these are functions that take in types and return types, right? And so common type is a trait that takes in multiple types and gives you the common type between them. So if you give it an int 32, an int 64, and a double, the common type for that is a double. So this is all part of template metaprogramming. Okay, so we don't have ns here, but we should have all of Clojure core compiling. So, oh, that means we succeeded, and then it's only because we didn't load Clojure core here. We compiled Clojure core. We can verify this by checking core libs, and we see Clojure core.o. Yes. Oh, that's good. I told you I was feeling good. I could smell it. Cool. So now if we watch this, we're gonna start building these nREPL doodads. Oh, or we're gonna crash, hard crash. What's up? So we failed an assertion that the bottom 3 bits of a pointer are 0, which implies that we have a bad pointer. Otherwise, not a lot of good info. So what I want to do is, let's go back to compiling just a bit of Clojure core, 500 or so lines. Okay. And then let's go back to adding this in. And then we'll just see if we can do some basic stuff with Clojure core. We don't have refer, do we? No, we don't. All right. So we don't have print line. we're not gonna have everything. But we can always do interop. Print line expects a sequence. So this works. So that means that the closure core that we have, it can be loaded. Oh no, I haven't called any closure core stuff yet. Okay, that called closure core stuff. So it does work. And then we'll just bring in a little more so we can actually have normal print line. All this works. Let's compile AOT. We don't have defen. Oops. We don't have NS. It's quite a bit. 72. Yeah, I mean we need basically all of closure core for this. We'll try it. Let's take a look at this code gen anyway. Yeah, so all these, there are no unboxed literals here. All these are boxed because we're passing them directly into print line. And so that's why we have small integer refs and small reals, bools. They're all refs. Yeah. So this, if we try to compile it now, it just reproduces the same problem. Okay. Well, let's take a look at the debugger for this, because I don't know what's up. That's optimized out. We got to go to 5. Whoops. Lovely. Let's go to 6. Oh, what? That's interesting. We're creating an integer. We're creating an integer. We're creating an integer. And we gave it. So we had integers here. And they looked fine. Mm-hmm. Are we initializing? Okay. Let's assume that we have a separate function. So we're gonna define a template type name, args, void print line that takes in args, and let's say it does nothing. That fails. Right. Yeah, we'll do compile module. And we got to remove ns. What? Oh, okay. Never mind. Yeah, so here's our function. And when we have all of our lifted globals, and then when we call, we just use those, and we don't initialize them incorrectly. Okay, there goes that theory. This looks great. There's nothing wrong with this. Shit. Initializing an integer. Yeah, I guess we got to dig more into that backtrace, figure out what's going on. long was that taking before? That just took a minute. Yeah, a minute. So this does not fail. If we use normal print line, this still does not fail. It's only if we introduce the ns macro that it fails. Ns macro. Noted. Because we see there was macro expansion here. Okay. So this is the really low value, certainly not a valid pointer. What are we in? We're in integer. Yeah. Like maybe that's a valid small integer. Could be that we're treating an integer as a small integer. That's what it is. That's what it is. Oh, what a relief. So yeah, in debugging this, I see that we have a boxed integer object here, and the data member of it basically is supposed to be a pointer to some data, but it's actually this very small value here, right? And so this very small value is this like 189,000, and small integer ref, they actually store their number in line. And so their data, which is in the same position, is just a 32-bit integer that's stored in that spot. So I'm pretty sure that the problem is that this is not actually an integer. This is a small integer, but we're treating it as the wrong type. And we're treating it as the wrong type because in the literal code gen type, we used to do something different for integers, and then we changed that when we first implemented everything. We moved everything to native types. Then when we went back and we tried to break things up into sometimes native type, sometimes box type, we didn't actually add that back in here. So I think that if we do a codegen type search here, we're going to find yeah. So what we were doing was we were checking. We want basically all of the minuses here. So what we're going to do is if o.getType is equal to, we don't need that, then remove this, and remove this, and then that's basically what we want. So let me save this to fix the formatting. So if the type is an integer, then grab out the integer data and then check if the integer fits inside of a 32-bit integer. And we do that by casting, this is ISA 64-bit integer. We cast it to a 32-bit integer and see if it's equal to itself. That tells you if it fits within 32 bits. If so, we want to use a small integer ref. Otherwise, we'll use an integer ref. I think this fixes our problem, because previously we were just using integer ref for everything, and that was a problem. So let me delete the core libs and then try again. So I believe I have all of Clojure Core. No, I don't. I only have, well, I do have everything up to NS, which should be everything that we need probably for the nREPL stuff as well. So let's see. We'll watch. Okay, so Clojure Core is compiled. That's good. Still going. Okay, so unable to resolve the rest of other shit that we're trying to access because we haven't compiled all of Clojure Core. So let's just save it all. Oh yeah. Oh yeah. How are we doing? How are we doing? Where's my nREPL? There is quite a bit of slowdown. I don't know why that is yet. Assuming it's still gonna work. I don't know why that would be. But yeah, this is taking quite a bit longer. It crashed. That's why. That's why. So we didn't compile, let's see, core libs, classes. This is not helpful. Core.o. Here, phase 1, Clojure Core, and then here, phase 1, okay. I think this should work fine. Yes, it does, and it's very fast. And so it's this one. This one crashes. Stack Overflow. Okay. So we are evaling eval. We added CPP literal. So why? What is it that we're not handling? X2 code string. No, to runtime data. To code string. Ah. Why? Why is evaling? What? What have we changed? I'm just gonna log it. We only added CPP literal for AST expressions, and we have an overload for that. Did we not forward declare that, and so it doesn't find it? Fuck. I bet that's the problem. Ah, yep. Yep. So the problem is our function was there, but because it wasn't forward declared and it was defined below where the recursion happens, the overload was never selected. In other words, C++ shit. Tricky. Yeah. I'm pleased I caught it though. Well, let's verify that that's actually the case first. All right, so I'm going to cancel that and I'm going to do this. Okay, no immediate crash. And then binary operator. Okay. Now we're moving on. Binary operator. So this is where we're trying to assign a string to a string in closure string. Closure string. What was that? 213? 218? So here we have C string as our loop variable. And so first off, I noticed that was 13, which was also the number that we saw before when I said we had a static issue where the very first thing was going to be set to 13. Well, we had a static in one function that is the literal code gen type, and then we had static in another, which was the actual C string type. And so we had that same bug in two places. I just had to fix that in another place as well. So that would have been some more undefined behavior. But I don't think it's going to fix this issue because that was still 13 and 13. And so now it's just going to be like 1 and 1. And there you go, 1 and 1. So how do we fix this? Had to take a phone call. How's the progress? Making progress. So we made it past those issues that we were seeing, and now we're on to more type analysis issues. So in particular, we have an issue here where it's complaining that well, actually, that's not the correct one. This is the correct one. It's complaining that we can't assign char array of 1 to a char array of 1. And the reason why it's trying to do that is that we have a loop here where this out variable of the loop, when we recur, needs to be assigned. So loops are handled by mutating the actual variable that's part of the loop. And the type of this is char array of 1. It's empty, but it's char array of 1 because the one thing in there is the null byte. And I think we just need, so we need smarter handling here, but I'm just wondering how we want to do this. So in this particular case, when we recur, we're not actually recurring with another C string, right? We're actually recurring with a boxed string instead. And so maybe we need to more intelligently check not only the initializer type of a loop, but also each recur, and then find the compatible type, just like we had the compatible types for the if branches. We need to find the right type to like update the loop type to. This is a tricky case though, because like this code needs to work. The fact that we're using a native type for this needs to be behind the scenes. This code works in Clojure JVM, so it has to work in Clojure. It has to work in jank. But it's going to require being a bit smarter about how we handle loop values. And like a lazy way out of it would be to just say, okay, well, for loop things, we should just, we could just box them. But we really don't want to do that because loops are like the thing that needs to be fast, right? And so being able to box Being able to leave loop values as unboxed would be great for performance. That's what we want. Do we want loops that are strings to be unboxed? Like loop values that are strings? Probably not. But maybe. But probably not. So maybe for loops, we actually use a slightly different logic where we'll leave integers and floats and bools as unboxed, but we're going to box strings. Because I just don't know how, like, mutating a C string is going to make sense. Rewrite everything in Rust. We could do that. You could just have Claude do that for us, right? Should fix the problem. All right, I don't have much more time before I got to go make dinner, but let me try to do a quick hack for this string stuff, and then we'll see if we run into any other issues or if that's the last one. Hey, Sir Elfman. Hope you're doing great. Oh yeah, if we rewrite jank in Rust, we'll make sure to piss off all sorts of people, even the Rust people. You just got to get everyone right. Okay, so analyze loop. Honey equal? Is that a typo of HoneySQL? Or is that a separate library? I'm familiar with HoneySQL. Or SQL if you fly that way. But yeah, that's a popular one. Okay, so here's all of our shit. Ret data first equals loop. Oh, it's a separate thing. Okay, I've not used that then. Expert type. If it's void, convert it to nil. Aha. So we already have a check here for mutable loop bindings and that we use a mutable type. So I think what we want to do is we want to check if it's a C string. And I think we want to put it above this. So we don't have a predicate for this. Let me just hack one in right now. Is C string. And so what we'll do here is we'll just say if is C string type return untyped object ref. And then here we'll say if CVP is array type and is array, now get array element type, get canonical type is equal to char type. So if it's an array type and the element type is char without CV, also forgot to add const there. All right. We'll check this last thing, see if this works. And then we'll wrap up. Yes, we'll need to put in a conversion for this. We'll need to put in a conversion. All right, so I'll wrap it up here because we're not quite done, but we do have, so we have a to do here for the next step. We're really close though. We can compile all of Clojure core, but we just fail when we're compiling build core libs. So we can compile all of Clojure core and we can compile most of the nREPL server, but we choke when we get to Clojure string because of this loop case with the string literal, and that's a good one. That makes sense. So I patched this so that out will be boxed. But we still need to then detect that case and then retroactively add a conversion so that way we don't try to initialize our literal or our boxed object with a string literal, which is exactly what's happening if you take a look at this right here, is that we have this S9 is an object ref and we're trying to initialize it with right here a pointer to const char. And so basically we've said, okay, out should be a boxed object, but then we're still trying to initialize it with a C string. So I have a to-do in place to detect this scenario and then handle that. That way we can convert this. But I need to run and make dinner. So I'm pleased. We got a lot done today, and we're very close to having this fully working with Clojure core and REPL. Now, we still need to run the whole jank test suite after that and verify that all the different several hundred cases that we have actually works just fine. I'm sure that we're going to run into compiler issues there as well that we're going to need to work through. But it's good progress. Very good progress. Very good progress. I'm pleased with that. I had fun. Hope you guys did as well. Thanks for hanging out. I'll catch you next week. And I don't know what we're going to be working on, but we're going to be hacking on some more jank stuff. You bet. Always. That's what we're doing. Anyway, have a good one. Adios.